Okay, thanks everybody for attending. I'm Brian Rowe, and I'm going to be presenting Fostering a Data-Driven Culture with Interactive Data Analysis in Slack. It's essentially talking about the project that I've been working on lately and how you can make the analysis process a lot more efficient than what it's like right now. So uh, before we actually get started, I want to I'd like to, take a moment to thank our sponsor, which is the CUNY SPS Masters in Data Analytics program. It's a 3-year part-time master's program, and it's characterized being an online program. So, we have people from all over attending the course, and you get industry leaders as the teachers of the program. I am actually one of those teachers, and the program is actually nicely run, and you get to learn a lot of good information about data science analysis, some theory, a lot of applications, and I encourage you to check it out. So a little bit about me. I founded Zato Novo, which is the company in 2013, essentially as a data science R&D company. And so I develop a bunch of different models for different industries, primarily in finance and also social media, some in the legal space where I've classified contract clauses. I've done a fair amount of analysis around predicting consumer spending and predicting credit risk, also portfolio analytics for trading. Now I'm more focused on creating a more general analytics platform for businesses, and that's going to obviously be the subject matter for today. So let's dive into the actual presentation. The question on everyone's mind these days is really, what does it mean to be a data-driven organization? And everywhere you look, people are talking about this concept of being data-driven. And we're going to answer that a little bit through quotations from industry. Tableau, which is an analytics software provider, they say that data becomes a part of the everyday, the day-to-day conversation. And so this idea that data is ubiquitous and we're all talking about it because it's around us and it's become more integrated into how we think about measuring the performance of our businesses and just understanding the world around us. For IBM, they look at data as being the strategic asset and central to decision making. We also see this with the Harvard Business Review, where they talk about the same thing, where there's also this emphasis on transparency, which we'll actually revisit a little bit later in the discussion. So one aspect of data-driven organizations that I think is very important is this understanding of relationships that span the organization. So when you think about a lot of analysis right now, typically they're siloed in these different areas of the business, like marketing, engineering, customer service, human resources, project management, things like that. And what's going on with like the data-driven movement is that you're kind of moving beyond these silos and starting to ask questions that span the different business groups. And so, we start thinking about how one area can affect the performance of another area, and really being able to analyze those relationships and seeing what the impact of decisions are on a more holistic scale. So how does collaboration fit into this concept of a data-driven organization? And that's a key part of what this discussion is about. And McKinsey, they look at it as really providing these tools that facilitate decision making. And so they're focused on frontline managers that have to make these quick decisions with as much information as possible at the given time frame. And so then the immediate follow-on question is, how do you get the information to make those decisions? And if you think about traditional processes for this, there's usually a dedicated analyst that embarks on a project, and then they have to go to IT, try to figure out where to get the data, figure out how to generate the reports, and then provide something, and then there's this turnaround, and it can be this fairly arduous, long, tedious process. And so, as things become more reactive, the question is, how can we do this faster? So this is where this concept of data-driven collaboration comes in, where it's really more of a holistic perspective around collaboration, where everyone is enabled to use data to make decisions. And so instead of looking at specific analysts who have to work with IT to get the data and then conduct this analysis, really we're democratizing the whole process. And so both the data and also the analytics functions are easily accessible and available to anyone in the organization. Anybody who has an idea can really just play with the data, make a visualization, or figure out how to create a relationship or find this relationship between the data, and then present it to people so that they can make decisions. And you don't have to take my word for it. The Harvard Business Review says exactly the same thing, where you can enable individuals throughout the organization to be more innovative and independent. VentureBeat even points to how data can empower junior employees to make these decisions, because again, everybody has access to the data, everyone has access to the analytics functions, and so that in and of itself is empowering. Of course, the question is, how do we actually get there? And what I like to say is that collaboration is really only possible with transparency and accessibility of data. And this was echoed in one of the quotes from HBR, where they mention this data transparency. So let's look a little bit more about how we can get there. Really, the key is having, well, as McKinsey says, it's about identifying, combining, and managing these sources of data, right? And they come from all places. And what we see is that this is actually a quote from earlier in the presentation, and now I've just kind of expanded one of the ellipses. And what we see is that there's this need for processes and systems that can provide access to and the ability to analyze data. And that's, it can be challenging to actually find that. And so the need is to have these tools that make data available and make it easy to analyze the data. But in reality, doing this is very hard. It's in fact rather non-trivial because there are a lot of moving parts. It can be major initiatives for IT departments, and you have to have a lot of buy-in from the top in order to invest in these sorts of projects. Now, bringing this data together a lot of times can look like a Rube Goldberg machine, because there are these moving parts, and they weren't designed to talk to each other, and so the process of actually getting them connected and whatnot can often seem rather comical. And because of this, the history of how the systems were created, it creates a lot of complexity, and that complexity ultimately will impede progress in becoming a data-driven organization. And as McKinsey says, this can often take years. And as the Sagrada Familia, we know that sometimes it can take centuries. But businesses don't really have centuries or years to make decisions, and so those delays end up becoming opportunity costs for businesses. So obviously, we still make data-driven decisions on a day-to-day basis, but they're not as clean or as efficient as we'd like them to be. So how do we do this right now in terms of the ad hoc solutions that kind of get around the long time frames of an IT project or the buy-in or the investment that's required in order to bring all this data to good. In the ancient times, we pretty much used Excel spreadsheets to share this data, and we would do an analysis there, pull in the data, and then ultimately we'd have to share it with somebody else by opening up an email, sending it to them, and then they would get it, and then they would open up the spreadsheet, make a change, and then they'd send it back. If you had multiple people working on the same spreadsheet, then you had to worry about version control. You had to worry about if somebody changed, like a function in one of the cells, and then how do you merge that all back together? And so collaboration felt very antiquated and rather difficult to accomplish. So more recently, we've made some incremental improvements on this, where now we use tools like Google Spreadsheets, which makes collaborating on the spreadsheet part much simpler and easier because everybody can interact in the spreadsheet at the same time. The difficulty with this approach, though, is that you still have the siloed data within the spreadsheet. So if you create these functions to transform the data in a particular way to view these relationships, if somebody else wanted to use that function on either the same data for a different analysis or on different data completely, it becomes very difficult to share that because you've got these functions embedded in the spreadsheet that's not really designed for anything beyond the immediate analysis. And so it's inflexible despite the collaboration. Another way that people get around this is to use dashboards of one sort or another. Tableau is a popular software analysis platform where you can create dashboards fairly quickly. There are a number of other competitors out there. I'm not advocating one over another. The main thing is that with dashboards you're given a more of a visual view of a lot of different data that is intended to be digested fairly quickly and provide the summary of heartbeat of what's going on with your organization. The challenge here, though, is that to make changes to this now has this development cycle embedded into it. It's not very easy to change the overall nature of the analysis. So you'll see some tools that have interactive sliders and some fields to change parameters, change bounds, maybe zoom in, zoom out, but ultimately what you're doing is drilling into the existing analysis or data, but not necessarily changing it. And that again impedes this, the progress around collaboration. So what ends up happening a lot because of the deficiencies of these systems is that people often resort to just huddling around a computer and pointing a finger and saying, oh, can you change that here or make an edit here? And clearly this is an inefficient way to collaborate. So what is a better solution? And before I move on to this next slide, I do want to just let people know that at the end of the presentation we'll have 10 to 15 minutes for questions, and you can actually submit questions during the presentation, and we'll answer them more or less in the order that they arrive. So go ahead and type those in, and when we get to the end, we'll walk through those. So okay, so what is a better solution? It's actually something that is a little bit unconventional, but actually happens to be a great solution if I say so myself. The combination is Slack, which is the enterprise messaging tool, and PanApp, which is my my analytics platform that I've been developing. So Slack, for those who are not familiar with it, is essentially a communications hub for the whole organization. What differentiates it from other chat tools is really this concept of private chat rooms, which they call channels, that are invite only. It's semi-private because it's only for your organization or team, and you can you have a lot of these service integrations. And what really that means is that because we have so many web services and web applications out there these days where you just go on the web, like whether it's Salesforce for customer relationship management, if it's Zendesk for customer service, if it's Trello or Asana for project management, if it's GitHub or Bitbucket for source code management. All these tools are now available online, and we have these workflows around them. And what, part of the brilliance of Slack is that they've created an API where the events that represent activity in those tools can be routed directly into Slack, since people are already communicating there, and then they can see what's going on without having to check these other tools. And from an efficiency perspective, that's really great, because that means that there are fewer distractions and fewer places that you have to move around just to get information. The result of this is that Slack has become this de facto data hub for all these organizational events. And you can essentially go to Slack and you can see the status or activity across your whole organization in just a single place. Now, the missing link in all of this is that it's really just event-based data, but to do an analysis on it, you need some way of being able to translate that into a structured data series. And that's what PanApp does. So PanApp is an interactive analytics environment. It automatically collects and structures those events into data series, and there's a bot that interacts, listens, and responds to that Slack activity, so you can actually do your data analysis directly from Slack. And that way you get all the benefits of the transparency that's already inherent in Slack with a tool that enables you to test your theories and hypotheses on that activity without a lot of ceremony or hassle. So I like to say that the combination of Slack and Panoptas is data-driven bliss, and hopefully you'll see that too as we continue in this presentation. So getting to the first thing that people like to see is what sort of visualizations can you do? For this example, this is a screenshot from just some demos that I did, where you issue this bang command, and I imported the iris data set. For those of you in data science, you know that this is kind of a canonical data set that people use for machine learning for classification. And so it has 3 different species of irises, and then it lists the sepal length, the sepal width, the petal length, petal width, and then you develop different algorithms against that to try to classify the different points. And so it's a nice, easy set that you can use for other purposes. And for this purpose, what I'm showing is that I load that data directly into Slack, and then I just do an XY plot on 2 of the columns within that data set. And then what PanOptas does is it creates the plot and then pushes it directly into your Slack channel, so that everybody who's in your channel can view the data and then can also actually execute their own commands on that data. So here are some other things, other visualizations that you can do within PanOptas. There's histograms for a single data series. You can do just regular line charts, and add as many variables as you want. It automatically gets added to the chart. You can apply functions to the data, and it'll transform it first and then plot it. So what you would expect if you're using like R or Python, except for it's just directly in Slack, and you don't have to set up any of the infrastructure behind it. You have to set up the databases. Everything's persisted for you. You don't have to worry about like the data importation, because it's automatically handled for you. You just work with the data and get to the insights that you're looking for. So one of the key questions for these type of systems is, well, how do you get the data into the platform? And for PanOptas, you can load it through back-end systems and whatnot, we can do that for you. But the easiest thing to do is just drag and drop directly into your Slack channel. It will take CSVs right now, it will take other things later, and the moment you do that, you can set a title for the file, and then that title becomes the name of the variable within the system. And then that all the data within that file is now accessible to anybody in your team, and they can work with it however they want. So, you know, the emphasis here is that it's immediately available and there's absolutely no IT involvement. You just do it on your own. And, you know, if you think about how this compares to the old Excel process of writing macros, this is a lot more convenient and just, you know, fun to do. So as I mentioned, there are a number of service integrations for Slack, and these are just, you know, a handful of the ones that are available. They're actually, I think they're adding, I think they're over 100 now, and they keep on adding, and then, you know, other providers have additional integrations, and it really does run the gamut of your organization. If you're not using the, you know, legacy mainframe style systems, many of the business functions and operational systems are now available online, from accounting to, you know, sales systems, project management, customer service, and all of these systems generate events based on the activity within the system. And all of those events can be routed into Slack, and through that process, they can automatically be transformed into a time series that you can analyze in pandas. That is, this is an example where we're taking a Trello card. So for those who aren't familiar with Trello, it's a simple project management system based on Kanban, which I won't get into, but the idea is that you have these cards that represent different tasks or use cases, and they're in different columns. Like you have your backlog, you can have like a column that represents things that are actively being worked on, you can have a column for things that need to be deployed. It actually comes from Toyota back in the 1950s as part of a way to implement just-in-time manufacturing. And so there's a long history behind it. For software, you can essentially track the progress of different activities. So in this example, I was creating the website for panoptas, and when I moved it from the backlog to active, what you can see is that panoptas captures this event, and then it automatically creates variables that represent these events, and it increments one, which would be the active board, and then or active column, and then it decrements the backlog where it came from. And so what that means is that if you think about this from a time-based perspective, each of these variables is now going to represent that activity over time, and then you can do whatever analysis that you want on that to see whether or not, you know, are there periods where the backlog gets too full? You know, is there a relationship between like the rate of change in the backlog versus the rate of change of deployments, things like that. And again, you know, this what this demonstrates is that this data is coming from disparate sources across your organization, but it doesn't take the years that McKinsey or HBR are saying it takes in order to do this. It actually just takes seconds, because we already have this data hub where all this data is going into. It's just a matter of collecting it and transforming it into a usable time series. And this is clearly beyond traditional IT capabilities. That's why you have a data science R&D company doing this. So the what that means in terms of, you know, pushing the boundaries is that you can get to this level of collaborative analytics where through the platform you can create these functions, and this, you know, reflects what I was saying is a deficiency of the Excel or the Google spreadsheet model, where you can't really share these functions across a single spreadsheet. But within panoptas, you can create a function, and then that function is persisted within your particular instance of panoptas, and then anybody can use that, and you can actually append to the function authorship information, description information, so that it makes collaboration more, easier, because then if somebody has a question about what the function does, it's already documented. They know who to go to if there's a specific person who's maintaining that, and the whole process becomes just very smooth in terms of sharing data and also sharing functions that process the data. So a little bit about, you've probably seen in some of these commands this bang pes. So I just want to talk a little bit about pes and what that is. Pes is a programming language that I created for panoptas, and you can see that it's a clever abbreviation of panoptas, and it also happens to be a popular candy. What pes is really, it's designed for data analysis, and so I use Python and R a lot. I've also taught ML actually at CUNY. So I have an affinity for programming languages, and because I've done a lot of data analysis, I've seen some of the pain points that are commensurate with these languages. And so my goal was to create something, a full-powered language that you can do the same things that you would do in Python and R, except for the syntax is simple enough that it's accessible to any business analyst that may have experience with Excel, some SQL, but not necessarily the full-blown syntax of a Python or an R. And so it borrows heavily from these other languages, including the concept of native vectorization and data frames as like the standard data structures. And it's also built on top of NumPy and pandas, which means that you can actually access many of the functions that you would use in those systems directly within the platform. The syntax, however, is much simpler, and the way you index and slice information is much more consistent than you get in pandas, so it's kind of this, hopefully a best of both worlds. So commands within pes are prefixed by a bang pes, and then you can, like any programming language, you can specify, you can assign values to a variable. And in this example, I'm simply calling rnorm with 10 with a parameter of 10, saying I want 10 elements, and this is very similar to R, where the function signatures are identical to R. There's no point reinventing the wheel there, and you get this data series back. And anybody who's familiar with pandas will see that it's really just printing out the pandas data structure, but the indexing has been modified to reflect more of R semantics, and the slicing behind the scenes is also much more consistent. So that's a little bit about the usage. You can call summary function like you have in R, and then it'll automatically print out summary information on that variable. You can see that for simple commands, you actually don't need parentheses, which again is intended to just simplify the syntax for people, making it a little bit easier to adopt. And with this, the idea is that essentially you don't need dashboards in the traditional sense anymore, because you get the power of self-service reporting, right? Where when you need the information, you can execute a command and then it'll print it to the screen. Yeah, obviously, like at times you may want to see, like a more canned version of that, and that would be a good use of a dashboard. But if it's really just to see, just to get the pulse of something very quickly, or you have an idea, or like some event happened and then you want to see how that's affecting something else, usually you don't want to invest the time or energy to create a flashy dashboard for that. You just want to get to the data, and you want to be able to write a few functions to transform or do the analysis so that you can see it very quickly, and then make a decision and then move on. And that's really what panoptas and pes is for those ad hoc data analyses where you need to make decisions quickly, but you don't want to wait years to have all the data integrated for you and have this nice clean system. You just want to get the analysis done and make your decision. So Thank you for listening. If anyone is interested in registering for the beta for Panoptas, you can go to the panoptas.com. We're currently accepting both beta users and also beta partners for people who want to have a little bit more privileged access and work with us in developing the platform further. And if you want to contact me, you have questions about either Panoptas or the program, feel free to email me at rowe@zatonovo.com. And you can also learn more about the data analytics program by going to sps.cuny.edu/datadrive. I guess let's open it up for questions. I think we've got about about 15 minutes. So let's see. So the first question is, what language do team members need to know to manipulate Panoptas? And realistically, you don't need to know any language. You should have some familiarity with some sort of scripting, whether it's like Excel macros or SQL. The idea is that it should be as simple as possible, but also have behind the scenes a very powerful programming paradigm. If you're familiar with Python or R, it will be very simple to pick up because the syntax is all very closely related to that. And if you go to Panoptas, there's a documentation section where we're putting together a number of quick starts and user guides on both the platform commands and then also the language syntax. And again, like the goal is to make it as simple as possible for people to use it. And eventually we may look at adding in more natural language processing capabilities so that there's a little bit of inference in identifying the intention of what you're trying to accomplish with an analysis so that people don't necessarily have to write syntactically correct code for every analysis. The next question is, how do we handle connecting many data sources? And the answer for that is that we have backend. So there are really two ways of doing that. There's the front end through the Slack API. Actually, there are three ways. There's the Slack API itself where data events are coming in, and we essentially install plugins that listen for those specific events, and then they will pull that data, parse the message, and then add it to a time series. We use time series data behind the scenes to store all the data, and that process is basically transparent to anybody who's using the platform. You can also manually import data, as you saw, and for other data integrations, we use industry standard ETL tools, open source, to pull in from what other systems you may want that data. So obviously, some people may want to bring in data from databases that internally, and we would use ETL processes to do that, and then just set up the appropriate event-based processes to get that, so it's a proper reflection of the other system. Somebody asked, is Panoptas a distributed development for data analysis? Actually, if you can elaborate on that, I'll get back to that one. The next question is, does normalization automatically occur? And that is depends. It really, for certain data series, normalization can occur if you're talking about the parsing process to clean up, to ensure that the data formats are correct. That can happen automatically. Obviously, if things get a little bit more specific, there may need to be user intervention in that. The goal is to make imputation and really the whole regularization process around data as automatic as possible, and then it's only when you need something very, very specific that you would have to make those changes. And so when it comes to parsing dates and times, when it comes to imputing data, the intention is to make that all automated so that people don't have to worry about that, and it really reflects the it really reflects the the sort of dirty secret of data science, that 80% of it is manipulating and taming data. And so there's a lot of pain there, and most people would rather focus on the analysis as opposed to actually doing as opposed to actually cleaning the data. And so wherever we can simplify and ease that process is definitely a valuable exercise. Next question is related to, are we looking for partners or resellers? Yes. If you're interested in that, please email me, and I would love to explore those possibilities. I do think that it's something that it can be integrated into other systems or products, whether it's other chat systems like Rocket Chat. We could even, for certain things, we could even connect it to Twitter if people wanted to. If people wanted to have that sort of interface directly on Twitter, there are a lot of possibilities, and it's definitely something that we're interested in exploring. The next question is, can you use pandas to call functions from R packages hosted on CRAN? Not right now, because it's behind the scenes, everything is running inside a Python interpreter, but there are clearly there are clearly a lot of interfaces for interoperability between Python and R, and it is something that we're looking into, is how can we expose a more complete analytics library and toolkit behind the scenes and make it transparent for people, so that they don't have to deal with the distributed computing and the scaling across multiple cores and all this, and they just focus on the analysis. So it's definitely on the roadmap, not something that you can do right now. Okay, so here's a clarification on earlier question. Does PanApp offer a distributed development environment for data analysis? For example, if person A creates a report and then person B thinks to modify it, will that person be able to access the analysis with their login? And yes, that's exactly the goal. Is oops, let's go back here. So because part of the answer is that the goal is you shouldn't really need a development environment for a lot of sort of ad hoc analyses, and because it's directly in Slack, like in this example, the iris data set is available to anybody who's in Slack. Eventually we'll add like permissions around things so that you can have a little bit of privacy and control that stuff. Right now it's all just in a global namespace, and anybody can access these variables. They can look up, find the variables. Eventually we'll add a search function so that if you're looking for a specific variable that represents something, you can actually just search the environment and see if anything is like that, and then work with that data directly there. And so again, because you're in Slack, it means that these variables like meeting length, meeting size are available to anybody who is in your Slack group, and they can do any analysis they want. So not only can they see the visualizations that you created, but they can also create their own, take those variables, do their own transformation and plot something else. And so for this is kind of a tongue-in-cheek analysis that use case that I was creating for essentially showing, the idea is that a lot of developers, well, not just developers, but a lot of people don't like long meetings, right? And so the idea here was that you could actually track the length of meetings and then the size of meetings, and keep track of those things. And there are actually commands within panoptas to automatically just add data to a data series. So it's very just very simple. You just do put and then the name of the variable and then like whatever value, and then it automatically creates that time series for you so that you can do this analysis. Then anybody could really just look at that variable, that data when they felt like it. Somebody might have inspiration and say, oh, I know, like I think that there's going to be this relationship, and then it's immediately available for everybody else. So in that sense, Slack becomes the development environment because you can do all that activity, all the programming, all the analysis directly there. You could do it in your private chat, directly with the panoptas user, so that you're not polluting other channels, or you could create a new channel where it's kind of your scratch pad or workspace. There are a lot of different options for how you can do that to interact. But the idea is that it should really be this fluid sort of interactive thing, as opposed to having this the structured process around it. Let's see. So how are we doing on time? Okay, I think we have enough for a few more questions. Let's see. So the next question is, how do you plan on overcoming the resistance of potential users to learn the PES language? I understand it's relatively simple, but team members may be resistant to change. Do you have training programs, etc.? Yeah, I mean, we definitely want to have training programs. We'll have a community board for asking questions. I mean, I think ultimately there needs to be a certain level of buy-in with teams, and the sort of gambit is that when people look at their current processes of doing things in Excel, doing things in Excel and huddling around computers to collaborate on analysis, or work on making a decision based on data. Like, people, to a certain extent, people already know how to program because they've used tools like Excel that introduce them to these concepts. And really, if you look at your current process, there's a trade-off in terms of, well, how much time will it, what's the investment to learn a language to make this easier versus, what's the cost of using my old processes? And so we'll make, every effort that we can to ease the learning process and make it as painless as possible. And then, over time, we'll probably start adding more natural language processing capabilities, so that people who are more resistant to learning can kind of ask the questions in natural language and then get the results that they want. The next question, does panoptas in the future plan to accept data input without relying on Slack and use its own API? Yes, absolutely. That would certainly simplify a lot of things. I think that for the paradigm is that there's a tactical aspect of, let's just get data into a system that's centralized, and that's the idea with collecting the data directly from the Slack channels. But then as there's broader adoption and it becomes more strategic, then yeah, absolutely, you would want to start skipping those steps and then just routing the data directly into the platform, and then that becomes it certainly becomes a faster process for that. I think we have time for, oh, actually we're out of time. So thanks everybody for attending the presentation, and again, if you want to get more information, just email me, visit panoptas.com, and don't forget about the School of Professional Studies Masters in Data Analytics program. It's great fun to be part of the program, and you can learn a lot. So Thanks, and hopefully we'll see you again.